Okay, our first slide is going to go over what we did on Friday. So go ahead and copy down everything. Remember, you can ask the substitute teacher very nicely to pause the video if it's going too fast, and then to play it again when you're ready to resume. Okay, go ahead, copy everything down. Okay, looking at this first example, determine whether the triangles are similar. If so, write a similarity statement. Remember, there are two things that have to happen if the triangles are similar. The sides need to be proportional, and the angles need to be congruent. Well, let's focus on the angles first. I know that this angle is 40, this angle is 90. How can I find this missing angle? Well, let's add 40 plus 90 and subtract from 180. So this missing angle here would be 50. The missing angle in the other triangle would be, well, let's see, 50 plus 90 minus 180, because the sum of any triangle is 180, would mean that this missing angle is 40. So, if I look at my corresponding angles, do I know that all of my angles are congruent? Yes. So I know that angles are congruent. The second thing is to check if the sides are proportional. Remember, that means that MN over DY, that ratio has to equal the ratio of MO over DA, which would equal the ratio of ON to AY. So let's check the ratios of each of these sides, these corresponding sides. So MN, so 12 over 4. Well, what does that reduce to? 4 goes into both. 3 over 1. So I know that the similarity ratio there is 3 over 1. How about MO over DA? So that would be 15 over 5, which reduces to 3 over 1. Perfect. And then ON over AY, well, 9 over 3, which reduces to 3 over 1. 3 over 1, 3 over 1, 3 over 1. So are my sides proportional? Yes. That first triangle is 3 times the size of the smaller. So since it has that same similarity ratio, I could say, yes, my triangles are similar. And let's write a similarity statement like it asked us to do. So I could say, since the angles are congruent and the sides are proportional, let's say triangle MNO is similar to triangle DYA. Alright, excellent. Alright, in this other problem, it says find x. And then it says the figures are similar. Okay. So this should be the figures are similar. Well, remember, I know that the triangles, in this case it's a 5-sided figure, so the pentagons are similar. So I know all corresponding angles are congruent and all corresponding sides are proportional. So I know that if I'm looking for x, that corresponds with, in this second pentagon, 5. 9 corresponds with 3. So I can use that as the other side of my proportion. Could I have used 6 and 2? Absolutely. It would give me the exact same answer. So now I'm ready to cross multiply. 3 times x gives me 3x. 9 times 5 gives me 45. Now I would divide by 3, so x equals 15. Okay, that was a little bit of a review from Friday. Now we're ready to learn the next material and the new material. Okay, we're ready to discuss the new material. This is section 8.3 in your textbook. Just like we had shortcut theorems to prove that triangles are congruent, we're going to have the same thing today, but proving triangles similar. So the first theorem we're going to discuss is the angle-angle similarity theorem. Go ahead, copy everything down, including the picture, of course. Remember, you can pause it any time and then restart when you guys are ready. So what this angle-angle similarity theorem says is, if two angles of one triangle are congruent to two angles of another triangle, then the triangles are similar. So on this picture, since I know that angle R is congruent to angle L, and angle S is congruent to angle P, that is enough to say that these triangles are similar. And right here we have written our similarity statement. Okay, let's apply this. Alright, our first example. Explain why these triangles are similar. Go ahead, copy everything down, including that picture. Alright, if you look at the diagram, it gives me that angle R is 45 degrees and angle V is 45 degrees. So I know that angle R is congruent to angle V. And the reason why is because they have equal measures. Okay. What other parts do I know are congruent? Well, look at this bow tie picture. Won't I know that this angle is congruent to this angle? And what would the reason be? Because of vertical angles. So I know that angle RSW is congruent to angle VSB and the reason is vertical angles are congruent. Well, look, I have one set of angles congruent and another set of angles congruent, so why are these triangles similar? It would be because of angle-angle similarity. Okay, great. Let's look at another example. Alright, another example. Go ahead, copy everything down and press play when you're ready. Alright, let's make this one a little bit more formal. So I'm going to make my statement reasons 2-column proof. I was given that MX is perpendicular to AB. Given. Well, remember, we know what perpendicular says. If I know this MX, is perpendicular to AB. Perpendicular lines create right angles. So I can next say that these angles are right angles. So let's say angle AXM and angle BXK are right angles. And my reason? Because perpendicular tells me I have right angles. Alright. I'm next going to have to say, well, if I know they're right angles, I know that they are congruent. Because remember, for angle, I need two sets of angles that are congruent in each triangle. So I could say angle AXM is congruent to angle BXK. And the reason is because all right angles are congruent. Did you see how they gave us that angle A was 58 and angle B was 58? So in my proof I could say angle A is congruent to angle B because equal measures tells me that it's congruent. Alright, so explain why my triangles are similar. Well, I can say triangle AXM is similar, one squiggle, to triangle BXK, and the reason is because of angle similarity. It did say write a similarity statement. That would be the last piece of my proof here. Okay? Alrighty, let's look at another way to show that triangles are similar. Okay, another way to show that triangles are similar is side angle side similarity. Go ahead, copy everything down, including that picture. So if an angle of one triangle is congruent to an angle of a second triangle, and the sides including the two angles are proportional, then the triangles are similar. So we have to add a little bit to this picture. So I know that this angle is congruent to this angle. That's great. We have to have at least one angle, one set of corresponding angles congruent. So here's the key part. The sides including the two angles are proportional. So that means that AB over RQ is going to equal the ratio of AC over QS. It has to be the sides including this angle. So it's this side and this side over this side and this side. So the sides including the two angles are proportional. So this is enough to say that the triangles are similar because of side angle side similarity. Alright, let's look at an example. Okay, take a moment and copy everything down. Alright, it says explain why these triangles must be similar. So far we know two ways to show that triangles are similar. Angle similarity and side angle side similarity. So this one looks like it gives me sides. So I need to double check that these sides that include the angle, and which angle am I talking about? These vertical angles would be congruent, and the sides that include it are proportional. So I know that I have angle ZVY congruent to angle XVW, because vertical angles are congruent. So I'm going to have to check and make sure that these sides are proportional. So I'm going to have to see, is ZV over VX equal to the ratio of YV over VW? So let's check this first ratio. 18 over 36. What does that reduce to? Well, what goes into both 18 and 36? Actually, 18 goes into both, so that simplifies to become 1/2. YW over VW, so here we would get 12 over 24. 12 goes into both, so that reduces to 1/2. So since these sides are proportional and the angles are congruent, this is enough to say these triangles are similar. So it says write a similarity statement, so I could say triangle ZVY is similar to triangle XVW by side angle side similarity. Okay, there is one more way to show that triangles are similar. On to the next slide. Okay, go ahead, copy down this whole problem. Hit play when you're ready to resume. Alright, this looks like it gives me a set of sides, angles, and another side. So that makes me think that we want to prove this by side angle side similarity. Let's start with the angle first. I know that angle R is a right angle and angle Y is a right angle from the diagram. So I can say that angle R is congruent to angle Y because all right angles are congruent. So in order for this to be proven by side angle side similarity, we need the angles congruent, which we have. We have a set of congruent angles, and we need the sides that include the angles to be proportional. So we need to show that QR over XY is equal to PR over ZY. Well, what's the ratio of QR over XY? Well, that would be 3/4. And what's the ratio here? 6 over 8. And then we could divide each one by 2, so again we get 3/4. So the angles are congruent, and the sides that include the angles are proportional, 3/4, 3/4. So I can say that triangle QRP is similar to triangle XYZ because of side angle side similarity. Okay, great. Next. Okay, go ahead, copy everything down that you see. Alright, we're ready to look at this figure. Do you see the two triangles within this picture? It looks like I have a smaller triangle, ABC, and I have a large triangle, ANK. So let's see if these sides are proportional. So AB would correspond to which piece of the other triangle? Well, it would be the whole side of the large triangle. So AB would go with AN. AB is 8. A mistake people make is that they say AN is 2. It's not 2. How am I going to find it? I'm going to have to add together this side. 8 plus 2 would give me 10. Alright, what goes into both 8 and 10? 2, so I can divide, and I would get 4/5. Let's see if that's proportional to the other side, if it has the same ratio. So AC corresponds with the large triangle, AK. So here I get 12, and I'm going to have to do the same thing. I'm going to have to add together, and I get 15 here. So what goes into both? It looks like 3. 12 divided by 3 is 4. 15 divided by 3 is 5. Oh, good. So I have the same similarity ratio, 4/5, 4/5. So that tells me that those sides are proportional. Well, there's no such thing as SS similarity, so that tells me I need something else for my picture. Remember when we did overlapping triangles? Do you see how these two sets of triangles overlap? Which angle is in both? Angle A. So I could say angle A is congruent to angle A because of reflexive. So are these triangles similar? Absolutely. Let's write that similarity statement. Triangle A, B, C is similar to triangle A, N, K, and the reason? Side, angle, side, similarity. Alright, great. One more theorem. Okay, the last theorem we're going to talk about is side, side, side similarity. Go ahead, copy it down, press pause, and then go ahead and press play when you're ready. So side, side, side similarity says if the corresponding sides of two triangles are proportional, then that's enough to say that my triangles are similar. So if these ratios, AB over QR equals BC over RS equals AC over QS, so these three sets of sides are proportional, that's enough to say that the triangles ABC is similar to triangle QRS. And the reason is side, side, side similarity. Alright, let's check out a problem. Okay, this is our last slide. Copy the sentence down, the first two sentences, and all three triangles. You do not have to copy down the green rectangle or the yellow rectangle. So the directions say which two of the three triangles are similar. Find the similarity ratio. So we have to go ahead and compare the sides in this triangle with the sides in this triangle. So I'm talking about, is triangle XYZ similar to triangle PRQ? So it looks like I'm given all three sets of sides. So I'm basically looking for, are the sides proportional? Let's check out the first set of sides. Here I have XY. If you notice, it's the longest side in this triangle. So that would correspond with PR, which is the longest side in the second triangle. So let's set up a ratio. This would be 33 over 40. Does that reduce at all? Well, no. So I'm looking for that as to be my ratio. The next set of sides, YZ and RQ, that's the next longest side. So YZ is 27, RQ is 30. When I reduce this, it looks like 3 goes into both. So 27 divided by 3 would give me 9. 30 divided by 3 would give me 10. Already, I can say to myself, the sides are not proportional, so these triangles are not similar. So those are not the ones I'm looking for. Let's go ahead and compare next XYZ and TUS. So the first triangle and the third triangle. Let's see if those are similar. Well, XY, the longest side, corresponds with the longest side, T, this should be S. So XY is 33 over ST or TS is 44. 11 goes into both of those, so that will reduce to 3/4. The next set of corresponding sides, YZ. So I'm looking at the next largest side, would correspond with US. So if I look at YZ, that is 27 over, let's see, US, which is 36. What goes into both? Well, 27 and 36, 9 divides into both. 27 divided by 9 is 3. 36 divided by 9 is 4. So again, I get 3/4. We have to check the last set of ratios. So XZ, the smallest side, and then this should be TU. Alright, is XZ, that's 18, over 24, which, what goes into both? It looks like 6 divided by 18 would be 3. 24 divided by 6 is 4. So do you notice? 3/4, 3/4, 3/4. So what is my similarity ratio? 3/4. So I know that triangle XYZ is similar to triangle TUS. And the reason is side, 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 similarity. And the similarity ratio is 3/4. Alright, great job today. I will see you tomorrow.